students, master's, PhD. We'll just show you some of the facilities we have here, which we use for doing our work. So we have here we have the battery and the capacitor research. So here is the potential stats. Here is battery placement unit. This one takes about 15 channels. This one takes about 5 channels. This one is also a potential stats. When we develop a supercapacitor of energy, we use this to check the capacity, intensity, and then look at how the possibility of it lasting for a long time. So this is what this does. And then after the measurement and so on, we shall know this one, there's a number of hours, how it's going to stay. We can use it just to 2 days to understand the behavior of the material that is developed. What we do here practically is more point cells. We develop point cells which are used in laptops and our wristwatch, and that's the making we do at this point. So, spark capacitors and batteries, we do that here.
Well, just something for the spark capacitors to use now. Those are very key to use here. What category is the battery? All, lithium, lead, and all this.
Yes, but we try to leave lead aside and on the metals and organic. The last one is waste. Again, the waste, try to carbonize it and then see whether
power source in things like guided missile, things like smart rockets. You know, they are like the power source for those devices, and they give quick power, to take those things to the target. So I expect super capacitors, to be like more have high energy density.
yeah, battery has high energy. So we just look at 2 of them. The one that has, sometimes we try to look at the hybrid, where we need high capacity energy, and then where we have power density. We try to bridge them and see which one will serve both dual purpose. We call it hybrid. Actually, as mentioned previously concerning the army coming to UNN, they visited our lab twice, and General they actually wanted to partner with us on developing their film that can be used for a sort of bullets. So, but before we could complete, then they retired. So, but we are still working. Like what we are doing here now, some of them are sponsored by US Army.
Okay.
The last they gave us was just 2003 to look at photocatalysis. I will show you some of the equipment. The UK government through a grant. So here, essential start of the US Army. Then we have the movie spectrophotometer, which we use to look at it. So with this, we complement what we have on the other side. So when we want to look at materials for energy, especially solar energy, we look at we use our UVVs. We use a good result, and which we use to do some of the work. Some of the equipment we use also for measurement. This one is UV visible range. What we did was to get oil from Niger Delta, then develop titanium dioxide, use it to degrade the oil and see whether we can get a clean water from it. So that's what we did last. We were about trying to publish that. And so this is what we use for that. We degrade with UV from this, and then it will break up the organic compounds. The water will be, the clean water will come up, and then the other ones will be absorbed by TiO2. And then that's all. This one, the microscope. So this actually for biological measurements, we look at how things move in the surface materials. So that's what this one does. Here is our PL. We try to use it to characterize materials and know how they behave under light. Here is the TIR. We also use it to look at the bonding in materials and then try to look at it from there. So here the kettle is the other side. The kettle which we use to look at efficiency of solar cell fabricated. We also fabricate solar cells. The last we did was on perovskite solar cell. And we were able to get a lot of this. Here is what we use for that coin cell.
One is blue box, other gas. You can obtain your sample. If you want to produce something at, let me just say, 99% pure, in absence of oxygen, you can use this. So this is like a controlled environment when you want to synthesize your sample. That's what this one do. Then the other one is a globe box. Assuming to the environment, instead of circulating within, there is a fan taken out. That's what we use this one for. Then this is electrospinning. If you want to form something like a fiber, so this electros, you make use of spit and nitrogen gas also for production. This is a centrifuge. This centrifuge is made when you are working on a powder, sizing using it from solution to nanoparticle. This is where the finishing product will come out. After centrifuging, there will be a separation of water and the particle. You now move to the next stage, which is drying and characterization. These are some of the equipment maybe if you want to mix something, instead of using your hand, we call it magnetic stir.
I got this one from Japan just last year. So what it does is use it to make electrode for cells, solar cells. So if you want a very nano scale of the material, you use this coating to do that. So I think
this was assembled locally, like they brought it in pieces. So we assemble here. If you watch the environment, most of things we use here, sometimes we help ourselves. When you go the other section, that SRD dark room side, you see where we normally maintain if the equipment spoil. The challenge we normally face is the pass. Like currently there is one I'm sourcing now, but they cannot ship to Nigeria because the origin of shipping is from US.
I was even happy when I had Prof saying that working with the United States and the UK. Though I think they should have gotten supply of these things to have the lab now look like state of the art.
What they do, is a grant and it's focused. So if they said this is what you are going to do, you won't go outside it. Like that potential start. What they wanted us to do is to use locally extracted leaves to fabricate supercapacitor for battery. So all they need from us is if you extract a dye from let's say mango leaf, you now use it to synthesize something like cobalt oxide. So from synthesizing the cobalt oxide, you now test whether it can work using the extract which you have. Over there, they don't use this type of things. So they want us to develop our own technology the way it suits our environment and see how we can use it.
No.
So,
yes, I have a question. Yeah. So, the working principle of this, there are some characterization that you calculate, like the atmosphere has some percentage, nitrogen, oxygen, carbon dioxide. So, does it have capability for extracting to a certain percentage to simulate
the what this does is, for example, if you want to fabricate a battery does not require oxygen. If you want to fabricate perovskite solar cell, it doesn't require oxygen. If you put oxygen there, within few hours it will degrade. So what we do is to put it inside this inert environment to do the synthesis, complete fabrication. When you do it, then you can now bring it out after you have fabricated to test in the other side. So that's majorly what this does. away from this. You point out a complete liquid from it. So if there is anything happening, you will see it here. So you can know the percentage that you are really working with.
So the program is from here.
Yes,
Yes, it's fully computerized. So you have to evaluate this and the other one, like the glove box, is
Usually for making the contact of a cell.
For this one.
And dark room. So in this dark room, we try to test solar cells. By December, we are going to bring equipment from Nano that we already have microscope here that if you shine light through it to your panel, you'll be able to get the cracks. So what we do here basically is to find out whether there is a crack in a solar cell. Over there you have all our PV cells that power this place. So what we are using here now is a solar.
you only see in that when the environment is that. That's why we got it here. So the panel will be placed here, current will pass through it. So when you use this to snap, if there is a breach among the cell which will now reduce the efficiency of the solar cell, you will know it will not pass through. It's like maybe you are under X-ray. If there is any bone along the line, maybe for leg, then you'll be able to detect it. Then before you bring here, when you finish solving any system, first thing you check is the efficiency. Along the run, if there is any mechanical fault or electrical fault, you know the efficiency will go down. When the efficiency goes down, you know that something is wrong. But looking with your normal naked eye, you may not be able to detect, or else it's a physical damage. But with this, you'll be able to say, this particular panel, because after arranging, one panel can affect thousands of panels. The same thing with battery, but here is mostly we use optical analysis to know what is wrong with this.
So the light here is not within the visible spectrum, it's within the infrared.
Yes.
Infrared.
Yes. If you just focus it like this, pass current through it, then
Yes. Infrared.
it's AC behind it. So that the AC, what it does is cooling the system, because anything else to it generates heat. So here you'll be able to obtain your crystal size, other Hall effect, and the rest of them from the result that you obtain. After it can, one important of this particular specification is that you can characterize your particle. You can also characterize thin film with the machine. But there are some of them that you can only use a particle on it. But with this one now, you can put your thin film direct and information from the system.
So that is for the characterization, both optical.
No, this
one.
This was for structural and
Structural analysis.
And then you now have to go for optical.
optical. So in engineering.